In our team, we have three members, Per, Jaejin, and Samal. We have decided to work on a Ames housing data set, which is describing the sale of individual residential property in Ames, Iowa from 2006 to 2010. The data has 2,930 observations and a lot of explanatory variables. So basically, when we were going through the data, we have noticed that it explains and answers to the question of a person who is interested in buying a house. For example, what is the quality of the house? When was it built? How big is the lot? And how many rooms are there above the ground? And so on and so forth. So while we were looking at the data, we have noticed that many variables do not have some values, and we decided to pre-process it before working with that. So the first thing, we have deleted the variables which had more than 80% missing rate. And the second thing, for variables with missing rate less than 25%, for numerical ones, we have replaced the missing value with the median. For categorical variable, we have replaced them with the mode value. For variables with average missing rate, we didn't observe many of them, but there was only one of the categorical variables, and we just added a new level for that. So the second thing we did is we ran the simple regression and analyzed the variance, and we saw that some variables are insignificant, and which means that they had high p-values, and by running the iterative model several times, we deleted insignificant variables. The third thing we did is we deleted the variables which had variance close to 0. And the last thing was highly correlated, meaning correlation was in absolute value 0.75, and we deleted one of the pair. So after we cleaned the data, we tried to find the significant variables among them. Yeah.
So the next part was to find what variables that were the most important variables for predicting the sales price. And in order to determine this, we used 3 different algorithms. All of them were based on the random forest algorithm. So here in our R code, we can see the first algorithm. And first we create a forest, and then we order the variables according to the importance using the importance function from the random forest package. And then we remove the 47 least important variables and save the 8 remaining variables as the most important. This is, of course, a very straightforward way to do it. The second algorithm is basically like the first one. We create a forest, we order variables according to the importance, and then instead of removing 47 variables at the same time, we remove just 1. And then we grow a new forest, order them according to importance, and then remove another variable. In this process, we iterate until we have only 8 variables left. The third algorithm is a little bit more complicated. We create 2,000 random forests consisting of 8 randomly chosen variables. Then we calculate the mean square error for each forest. And then we sort the forests in order from low mean square error to high mean square error. And then we create a subset of the 100 highest performing forests, and then we check the frequency of each variables in this subset of high performing forests. And the 8 variables that are most frequent in this subset is the ones we choose as the most important. And all in all, we found 11 different variables that were coming out of this process. and it's these 11 variables here. And for the next part, we're gonna look a little bit closer into the neighborhood variable and also into the year built variable.
So after selecting 8 significant variables, we decided to use the Tableau tool to see how the sale price is affected by the year build. So if you look at the picture, it is obvious, as one might have suggested, that the newer the house is, the higher the price will be. But we have also noticed here, we have also noticed here that there is a high jump and a sudden drop during years 2006 and 2009, and we tried to explain it by the fact that in 2008-2009 the market crashed. That's why the house of the prices were really low, and right before that market was thriving and the houses were really expensive. Also, we tried to estimate the house sale prices by 2020, and as one can see, the estimated price is around 15 million by the year 2020. So the next variable that we were investigating was how the sale price is affected by the neighborhood. And from here you can see that the average sale price is around 200K, and for neighborhoods like Old Town, it is logical that the sale prices are not that high, and they are below the average. And for some neighborhoods such as this one or this one, we didn't have enough data to conclude why exactly they're really below the average. And we also saw neighborhoods as this one and this one, and we are suggesting that maybe they are expensive neighborhoods. That's why the sale prices for houses in these neighborhoods are quite expensive.
From now, we will look at the diagnosis test, which was based on our variable selection method. The first one is to check for outliers. If you calculate the Jaejin residuals, it seems that there are several high value points. So, therefore, we used Bonferroni correction method for critical value, and we sorted out each point's residual t-value. So, if you look at this graph, there is 70 points that exceeded the critical value. So, we might say we excluded 17 points in data. So when you look at the adjusted R-square, it increased than the previous data. So for the next step, we will look for the influential points by using Cook's distance. When you look at each point's Cook's distance, there seems extreme points. However, the absolute value is quite low. But as a rule of thumb, we can exclude the points and see the regression outputs. So, as you can see, the adjusted R-square become higher than before, so we will continue the diagnostic test based on this new data set. So for the next step, we will look at the non-constant test. When we look at the residual plots, it seems that it is linear but not constant variance. So we did a BP test to decide whether it is non-constant. If you look at the p-value, it is too low, so we can conclude there is non-constant variance. To fix it, we will calculate the Box-Cox transformations. So as you can see, the Box-Cox transformations show us that lambda is near 0.2, so we chose the lambda as 0.2 and refit the model transforming the response variables. When you see the residual plots again, it seems to exist constant variance. And as a final step, we will check the normality. And in QQ plot, it seems like it forms linear, so we can say that the model has normality. This is the end of our diagnostic test. If you need more information, please read our final report.